Problem 6-33. The Howe Bridge is subjected to loadings shown. So we have 4 loadings, and we want to determine the force in members HI, HB, and BC. So we're going to want to cut it right through there, find the force in all 3 of those. Now I'm going to use the left half. So the first thing I need to do is find the reactions on A. Now by observation we can see that the A and the X is equal to 0. So we just need to know A and the Y. So I'm going to sum the moments about the point E. So we're going to go from left to right. So 40 times 4, 20 times 8, 20 times 12. And 20 times 12 and 30 times 16 minus AY times 16 equals 0. Sum all those up, move AY to the side, divide by 16, and AY equals 65 kilonewtons. So now we're going to cut the object there. So let's redraw it, because we have a new object. Every time you do a cut, you're changing, and in essence it's a new object. And then we have 3 new unknowns. AY now is no longer an unknown. It's 65. We still have the 30 here and the 20 here. And now we have a new object, and we can do 3 equations again. Sum the 4 moments and the forces. So I'm going to sum the moments about point B, because I have 2 unknowns. And I've just drawn these. One of these are going to go back, obviously. See if I put it in tension. The bottom will be in tension as it bows down, so the tension is going to pull in. So the top's probably going to be in compression. So if we think a little bit longer about it, it's probably going that way. But if you just guess and get it wrong, you get a negative sign and you turn it around. It's not a big deal. So I'm going to sum the moments about B, because if I sum the moments about B, it eliminates both of these, and my only unknown is up here at the top. So about B, 30 doesn't matter, or about B, okay, I got 30 down, I got 65 up, so negative 65 times the distance 4, and then plus 30 times the distance 4 also. And then we have 20 doesn't matter, it goes through it, those doesn't matter. So all we have here is FHI, and that's going to cause positive rotation, so plus FHI times this height here, which is 4, and that all equals 0. So FHI equals 35. Now I'm going to sum the forces in the Y direction. In the Y direction, I've got 65 up, I got 30 down, I got 20 down. And of my unknowns, all I have is the Y component of this FBH. So I'm going to say I have plus FBH in the Y direction. And that's it, that equals 0. So FBH in the Y direction equals 15. And that's a negative 15, isn't it? Because we move those over there. Oh no, subtract that off, you get 15, move it over, it becomes negative 15. And so this is a 45-degree angle. So FBH is equal to 21.2. I'll also call it negative because it's going down now. Now let's sum the forces in the x direction. And in the x direction, none of these have x. The only x we have FBH in the x direction. And we have minus FHI, which we already said is 35. And we have here's FBH in the y, in the x direction. We have FBC also. And that equals 0. Now FBH in the x, this is a 45-degree angle, so it's the same. So it's going to be 15. And we got negative, so it's actually going down, so it's going to be in the negative direction. So negative 15 minus 35 plus FBC equals 0. So FBC equals 50. And so this one, let's redraw it. It's actually pulling down, pushing down because our answers are negative. This is pulling back, so it's in tension. Pulling back, so it's tension. Pushing out, so it's a compression.